Hello, my name is John Broadwell. I'm an independent consultant at my company Broadwell Consulting Incorporated, doing embedded systems and medical device development, and I'm also the creator of the Serial Wombat open source project. Today I'm really excited to tell you that I've launched a new version of the Serial Wombat 18AB firmware, version 2.1.0. For those of you unfamiliar with the Serial Wombat chip line, these are chips that add capability through I2C or UART to other smart devices. They're designed to be hooked up to your Arduino or your PC or your Raspberry Pi so that you can add additional I/O capabilities, but unlike some other I2C devices, they take full advantage of the fact that we're a microcontroller to do interesting stuff, and there's lots of pin modes that you can mix and match to do many, many things. So the version 2.10 adds new pin modes and new capabilities. You can download the firmware yourself. You can see here it's up on GitHub, and program it using an ICD4 or other microchip programming device, or you can buy the chip in a kit along with PCB and support components directly from me on Amazon. Go to serialwombat.com and follow the link in order to be able to do that. Now let's take a look at what's new in the version 2.1.0 software. There's a bunch of major new features. Command capture and playback at startup. VGA Monitor Output. PS2 Keyboard Input. That's the IBM PS2 keyboard, not the PlayStation. High-speed clock output, up to 32 megahertz. High-frequency counter frequency input. We can keep track of counters that are running at megahertz speed now. On-chip feedback control, PID and hysteresis. The Serial Wombat chip can take an input and drive an output without any help from an Arduino once it's configured. Additional features are available for feedback control. We can go to a default value if we lose a communication. We can change the output rate of things. So if you ever have a servo that moves too fast, the Serial Wombat chip on chip can control how fast it moves. Output inversion and scaling. And there's a minor new feature, ASCII interface for resistance measurements. It's almost too small to mention it, but I brought it up because this was a specific request on one of the other YouTube videos, and I implemented it. If you ask for something in the comments below, I might implement that too. That's one of the fun things about having a relationship with my customers and being open source firmware. Other major new features. I've made consistent input filtering and averaging across all numerical input modes. There's outlier rejection. There's scaling and inversion. We can capture data to queue. And we'll talk about all of these various things in more detail through the rest of this video. First, let's talk for a moment about upgrading your firmware. Within a month or two, all of the version 2.08 firmware Serial Wombat 18ABs should be sold off of Amazon, and so you'll be able to get them directly with version 2.1.0. But even if you don't, it's no big deal. You can upgrade over I2C using an Arduino sketch. There's a link up above that shows how to do that. You can also update directly from your computer over a USB to UART connection using the Serial Wombat panel application for Windows. And there's a couple other ways as well. So take a look at these videos if you want to update your existing Serial Wombat chip, or if you get one of the last 2.08 chips that are in the supply line. This update to the Serial Wombat firmware requires matching Serial Wombat Arduino Library or an update to the C# classes. So make sure that you get the latest version. You can do that on Arduino through the library manager, and if you go to GitHub, you can also get the C# code. If you go through here, you can find any of the various classes, and the interfaces to the classes are listed here. Here's the VGA one, for example. There'll be links to the interfaces for each of the new classes in the text below this video. Let's talk about command capture and playback. This is a major step forward for the Serial Wombat 18AB chip, and essentially what it does is it allows the chip to operate in a standalone mode. It doesn't change what the chip is. The chip is still a command interpreter. You don't download code on it. But what it does is it allows you to give it a few commands that would be played back at every startup. And essentially, that's really, really good. Like if you want to drive outputs to a known state, suppose you're controlling a robot arm and you want it to go to a neutral position right off the bat after power up, or if you're concerned that a power glitch causing a reset might cause the arm to fall without the servo control, you can put initialization commands in there. It also allows the Serial Wombat chip to become a standalone signal converter. You can configure the Serial Wombat chip to drive one pin output based on another pin's input without help from the host. If you do that at power up, now the chip can become a converter. Suppose you just want to be able to control a servo from a potentiometer. You can do that just by configuring the commands to set up one pin as a servo, one pin as a potentiometer, and tie the two together. Or, introduced in this version is PID Control. By downloading, by sending the right commands and capturing those, you can make the Serial Wombat 18AB chip into a standalone PID converter, or a series of PID converters that work across different pins. One of the modes that I'm really excited about from a technical standpoint is the VGA Monitor Output. This is really a pin mode that shows the power of the PIC 24FJ256GA702. It can drive outputs fast enough to sync a VGA monitor and at the same time still do the other things that the Serial Wombat chip needs to be able to do to interface to your other devices, servos or analog inputs or rotary encoders or whatever. This pin mode has a driver available so that you can use the Adafruit GFX library just as you would with an OLED or TFT or other display. So it's really convenient that way. The only thing you need to do the hardware is the monitor itself, a VGA cable, and 5 resistors. It even does color, although it only can do one color for each horizontal line. So you can get red, blue, magenta, green, yellow, white, and one other that I'm forgetting. And so it's really useful for informational displays. There is a slight amount of jitter. Due to technical limitations, I have to use the SPI output, and it wasn't really designed to be used in a synchronous manner. It's a clocked output, but it works pretty well, and I'm really, really proud of it. Unlike other pin modes, you must use pins 14 through 18. The pins aren't configurable, and that's because the hardware requirements and the speed requirements for driving 60 frames per second, with 800 lines and, all those pixels that need to be driven required me to get rid of some of that abstraction and stick to specific pins. One of the things that I think is interesting is when you look into the Arduino or other hobby microcontroller solutions, a lot of the solutions require that to be virtually the only thing that you do. You can drive a VGA from, say, an Arduino Uno, but it can't really do too much else. In this case, through the clever use of interrupts and the SPI and DMA and other things, we can still have the Serial Wombat do just about anything it would normally do at the same time it's driving the VGA monitor output. So look for a video on that in the future. When it comes out, there will be a link down below or a card up above. And if you look in the playlist for the Serial Wombat chip on YouTube, you can see a couple of teaser videos that I did for that. The IBM keyboard input. Before USB, people used IBM PS2 interface keyboards. And there's still a lot of them out there on eBay and other places that you can get a hold of. And they're still used some in hospital and retail and high security installations because they have actually some advantages that over USB. But essentially, it makes it an easy way to add a keyboard to your Arduino. You can hook it up to the Serial Wombat chip. The Serial Wombat chip worries about all of the clock interfaces and data interfaces, keeping track of the shift keys, things like that. And so the Arduino can see a PS2 keyboard as a simple stream. Or alternatively, if you're wanting to do gaming-based stuff or real-time control stuff, then you can use the the key scan array mode, which lets you see which keys are individually pressed and released at any given time. So there's another video that will either be a card up above or a link down below on how to use the PS2 Keyboard Input. High-speed clock output. Now that I've done a lot of the basics, like servo and analog input and cap touch, I'm starting to get into exposing the capability of the PIC24FJ256GA702 out through Serial Wombat interfaces. One of the things it has is an internal reference clock that can run at 32 megahertz or 16 megahertz or 8 megahertz. And so this provides a nice way for one Serial Wombat pin to be able to output a really high clock signal. Note that because we run on an internal RC oscillator and not a crystal, the absolute value of that frequency can vary by up to 2%. And it has to be an integer division of 32 megahertz. You can get 32 divided by 1, which is 32 megahertz. You can get 32 divided by 2, which is 16 megahertz. But there's no way to output a 24 megahertz signal because we can't divide by 1.5. And the divisor can be anywhere up to 65,535. So as we start getting into those lower kilohertz ranges, we have pretty good resolution on the output that we want to provide. And that can be useful for a variety of different embedded systems things. Some of the cases where you might use a 555 or other timer to implement those outputs. The high-speed counter is kind of the flip of the high-speed output. And in fact, I implemented the high-speed output so that I could test the high-speed counter, which was desired by a customer of mine who was adapting the Serial Wombat firmware for a specific use. And there are two modules that are capable of doing high-speed count inside of the PIC. They're called MCCP modules, and you can count on them to count up to 2 megahertz, in some cases higher. And so you can pick up to 2 of them. Now, these are shared timer resources, and so you want to be careful about the order that you allocate those versus PWMs versus servos to make sure that you can get those. Otherwise, you'll get an error message back that said, oh, we've already used these MCCP modules for something else. So the frequency measurements, the counter measurements are exact because those are discrete. But frequency measurements, you're essentially taking a number of counts versus time. And because our RC timer can be off by up to 2%, frequency measurements are also only accurate to plus or minus 2%. But if you're using it as a counter where you're checking in with it periodically from your Arduino or PC or whatever, those numbers are exact. On-chip feedback controls. This one is huge. So already on the Serial Wombat chip, there's some availability to drive output pins based on input pins. An analog input can drive a servo, or an analog frequency, an input frequency can drive a PWM. Now we're adding the ability to put on each output pin a feedback control block. And so each output pin can have its own PID controller with its own set of PID constants that read from one of the other Serial Wombat chip pins. And so that creates a really powerful system where the Arduino, instead of trying to do real-time control, can tell the Serial Wombat chip, hey, I want you to take pin number 19, turn it into an input. Then I want you to take pin number 10 and measure frequency on that, because I'm going to hook that up to the Hall sensors on a motor. And I want you to use this P, this I, and this D constant, and I want you to sample every 32 milliseconds or whatever. And I want you to control this motor essentially with your PWM output so that I get an input on the Hall sensors of, 1 kilohertz or whatever, whatever it might be. So really, really powerful. And again, if you combine that with the ability to capture those commands and replay them on startup, you can create a standalone PID controller out of a Serial Wombat 18AB chip. And those are easily configured on the Serial Wombat application or through Arduino interfaces. There's a teaser video on this as well, where I controlled one fan with another fan using airflow. There's either going to be a card up above. I'm running out of cards. YouTube won't let me put like 20 of them on one video. Or check in the links down below for that particular video. Going further into moving the Serial Wombat chip into a world-class embedded systems controller, you can add rate controls. So for instance, one of the things you may do, if you have a robot arm, you may say, okay, I want to move the servo from 15 degrees to 45 degrees. But if you put that in one command, currently, it will make the servo try to swing as hard as it can. And ideally, with some things, you want them to move slowly. So the Serial Wombat chip, you can tell it, create a servo, but I only want you to be able to move this many number of counts in this many number of milliseconds. And so then it will automatically control the rate of change of that output. Could be a servo, could be a PWM, on chip, again, without any additional need for the Arduino or PC or smart device that's controlling the chip to have to check in. It just happens. Now the PC or the Arduino can check in to see how far along am I, how close to me to my target, but you don't have to. One of the other things we can do is outputs can go to a default state if communication with the Serial Wombat chip times out. You can set it up to say, hey, I'm going to check in with you every 250 milliseconds and reset a counter. But if I don't, I want you to put the throttle, put a servo to this value, which might be good for like killing the throttle on an RC car. Or if you're if you're creating an aircraft, a fixed wing aircraft, you might set it to slowly do a spiral so that if your main controller that's talking to the Serial Wombat chip, goes out, you get into a known state that hopefully will help you control your equipment in a way that won't cause damage. And I would say once again that the Serial Wombat chip is quite capable. It's not designed with functional safety in mind, and so you shouldn't use it for anything where serious property damage or human health could be impacted. But these kind of default states go a long way towards making sure that your equipment doesn't get damaged by some kind of a software error. The outputs can be inverted or scaled, MX plus B on chip, to simplify host side commands. That allows you to think in the commands that you send over in terms of degrees or, percent of total range of motion or whatever. And we'll have more videos on that capability in the future. The input functions as well have been unified using what's called a scaled input module. And what it means is that any input, whether it's an analog, resistance, frequency, counter, can be processed using the same set of functional blocks. And so that's really nice. They all inherit kind of from the same set of interfaces. One of the things that's really nice is outlier rejection. Sometimes with analogs, despite your best effort to filter or clean up your circuits or whatever, you get inputs that are outside of the acceptable range. And the Serial Wombat chip can simply substitute the previous best reading or good reading for an outlier so that your control systems won't go crazy acting on data that isn't valid. It's a glitch. And we can also input sample at known frequencies up to 1 kilohertz and have that data go into a queue so that you can retrieve synchronous data from the host, which can be useful if you're doing other filtering or real-time control or want to look at system responses for control systems or things like that. So I'm really excited about this release. Again, the firmware is available on GitHub, and look for within the next month or less. I should be sold out of the chips on Amazon. Chips will go out of stock for a short period of time so that I can let the old ones sell out before I ship in new ones. Then I'll put a note at the bottom of this video when that's happened so that you can be sure that any new chip you get is version 2.1.0 or later. And if not, update before that. And so let me know what you're doing with this and look for the other future videos. Subscribe to the page. That's how you can find out about new capabilities that are coming out with the Serial Wombat chip. And comment below with what other new features you would like to see. I've got a laundry list of videos I want to do, features that I want to add to the subsequent versions. Getting the Python library up to speed is one of the things that I haven't gotten to, because I just don't like Python as much as C++ or C#, but I'll get there. If that's a priority for you, then let me know kind of what's important, and I'll try to do things to make people happy. Again, other features, bugs, anything. Leave me a comment down below, or just tell me you like the chip or the project, or let me know what you're doing with it. I'd love to feature your video in a future update as a user thing. So that's all I have for right now. I hope you feel like that's enough. I've certainly put a lot of work into this thing, and I hope that you enjoy it. So look for the next videos and have fun and keep making stuff. The Serial Wombat firmware is available on GitHub and is constantly being updated. Subscribe below so that you can see the latest features and videos that come out as we fix bugs and add new features. The Serial Wombat open source project was created by Broadwell Consulting Incorporated. Broadwell Consulting Incorporated provides help developing medical devices with a focus on developing embedded firmware, which is compliant with IEC 62304, ISO 14971, and ISO 13485, as well as remediation assistance for products already in production. For more information, contact John at Broadwell Consulting. Support requests for Serial Wombat should be sent to help@serialwombat.com and will be answered on an as-available basis. Also, feel free to leave your question in the comments below.